world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space.
All right, hello and welcome, lads and ladettes, to Aether Roundtable 117. Tonight's going to be a reading night. It's the old BYOBC, otherwise known as the Bring Your Own Brenner Comp. So Mr. Brenner wrote two articles recently, so we're going to be going over those right now. And before we do that, special shout out to the 1 year anniversary of the first celestial theodolite measurement made. Was done last year, January 27th, at, what was it, 6:43:06 p.m.? I need to know now. It's going to bother me. All right. It was 43:06 or 07. I was close. All right, but shout out to the Celestial Theodolite and Dr. Mike, who helped advance the Flat Earth conversation when it was in desperate need of a boost.
Spectacularly.
Couldn't have come along at a more perfect time. All right, so following up on the Brenner comp here, we got, how can one prove that the Earth is round without using expensive equipment or resources? To quote the response that he's replying to, evidence can't prove any idea is true. It can only prove ideas false, says Mike Dunaway here in the answer, and he's right. And all serious experiments prove that the Earth is not a sphere and that it is not rotating. In my recent post, I have shown how obsessed scientific papers are to point out every step of the way that all the calculations are based on the premise of a flat, non-rotating Earth in a stationary atmosphere. Be it space agencies, military, atmospheric studies, radio signal studies, sound propagation studies, etc. Here is one from the collection where we find all the trigger words for the mainstream globe world in one short paragraph. Near sun, flat earth, firmament. If you guys haven't seen this one, I think this is from the CIA reading room or whatever, where they talk about the brightness of the firmament and stuff. So we'll read through here. So near sun halos, and also from the sun on the surface perpendicular to these rays. This dissertation contains a certain formula for the brightness of the sky, taking into consideration only the brightness of the first order and derived on the assumption of a flat Earth, and giving some conclusion derived on the basis of this formula. For a certain coefficient of transparency of the atmosphere, the brightness of the sky at any point is represented by the derivation of two functions, functions of which one is the function of the diffusion of light and the other is the function of the zenith distance of the sun in the observed point in the sky. Oh, that's interesting. On changing the zenith distances of the sun z from 90 to 0, the brightness of the sky on the almucanter of the sun's brightness increases, or the sun increases, first reaching the maximum for a certain value for z and then decreases. A method is also proposed for determining the brightness of the sky on daylight sky at any point based on measuring the brightness along the almucanter of the sun and of 5 to 6 points of the firmament located at various zenith distances. This method permits determination, and it's cut off from there. So an interesting paper about the luminosity of the sky based off of the position of the sun and the zenith distance of the angle at which you're viewing it at. That's
Looks like an almacanter is a circle of equal altitude, essentially.
an
Just
almacanter.
two step. Yep.
Gotcha. Gotcha.
And it's also using the sun as at zenith. So it looks like it's comparing the rate of contrast reduction to when sun is at zenith to when it's at the horizon, and there's a direct relation to that. And go figure. They're relying on a local sun to induce and calculate the brightness of the sky. Excellent.
Well, there's also a zenith distance ratio to, how much refraction they say there is too. At any zenith distance, you can do the the local temperature times the tangent of the zenith distance. And then I think they square that maybe. But anyway, either way, whatever that equation is, they also do this, they can make the similar thing. So bottom line, a spherical rotating Earth is only maintained in public opinion with constant false flag demonstrations and experiments, just like the ISS actors constantly fooling around, obsessed with convincing us that they are in a microgravity environment with spray stiffened hair, standing on the end, wringing out of water in a $1 billion electronical environment, and we're never doing any science work while the cameras are on, because these are the fairgrounds shows. Or fairground show acts, so they're just for funsies. Dude, yeah, think about that. On all those like 24-hour videos, are they ever doing anything in them?
They're doing backflips, playing guitar, and trying to drink water out of a bag. I think that's like the 3 predominant scientific experiments that they do.
It's preposterous, dude. All right. Among the most prominent of these misleading demonstrations is the Foucault pendulum, another impressive fairground showpiece. Houston's own pendulum just stopped because the mechanism driving it stopped. The reports from times to times before the driven pendulums indicate that they have a quite erratic behavior and of these contraptions, and one could switch the suspending thread end over end, for instance, to change the direction of the rotation, etc. Foucault himself wasn't too pleased with this, wherefore he invented another showpiece, the Foucault gyroscope, which seems to go totally unnoticed by the public, apart from the fact that the Collège de France, where the original was kept, had mysteriously lost it, and there are several later copies. So here's the Foucault gyro. All right. What this contraption was designed to show was the apparent wander of the gyroscope, a term still used in flight instructions. A carefully gimbaled gyro is supposed to reflect Earth's rotation by keeping its orientation fixed to the stars, which equals keeping an absolute orientation in space, as the gyros are what do, while the Earth rotates underneath it. Here comes the carefully gimbaled part. Like the pendulum, which needs the careful tuning, it takes days for the pendulum to be tuned to do what it's supposed to do. The Foucault gyro has a very particular arrangement that allows for the control rate of the alleged drift. Wow. Let's just talk about the rate of the apparent wander for a moment. If you go to all sorts of instruction videos, textbooks, United States Navy training film, and you'll always hear about the 15 degree per hour drift resulting from the rotation of Earth at 360 degrees in 24 hours. What is never pointed out is that this is only valid for the pole regions where very few pilots hang out. It is 0 at the equator and a gradient in between, so the drift would be different in every latitude, plus different depending on the plane zone motion, or in other words, not worth wrecking your brain while trying to figure it out while flying. You just regularly synchronize the gyro with the reading on the magnetic compass, and that's it. But that is true also for the drift of the mechanic friction and the energy loss, which makes the statement, quote, due to Earth's rotation, just a philosophical frosting on the cake, which, by the way, doesn't really stick, because once the plane is off the ground, it is decoupled from the alleged rotation of the ground. So the gyro is only used because it is much more stable than the nervous needle of a compass, especially in turns and turbulence. But the gyro doesn't know true north from a banana, so it needs to be slaved to a magnetic compass. Wasn't there just a discussion about the gyro compass, the magnetic gyro ones or whatever? You know what I'm talking about, Shane?
Yeah,
Was
Egg
this,
Shells put it forth a super convoluted argument where he thought it proved the rotation, and I think Galley set him straight with the fact that it has to be aligned, set to the GPS and the long lat, and then that's how it knows its position from which to process from. Otherwise, it has no idea.
otherwise, yeah. Well, it doesn't know a banana from north, right? It has to be told.
Yeah.
So yeah, it has to be slaved. Very cool. So here's the premise here: the gyro maintaining its orientation as it moves over the curvature of Earth. The apparent drift does not occur at the equator since the meridians are parallel. At the poles, the rate's drift is equal to 15 degrees per hour. The formula for the drift of the rotation is the apparent drift is equal to 15 degrees times the sine of the latitude divided by the hour. Back to Foucault. Because gyros do not wander due to Earth's rotation, as anyone willing to spend the time on a simple experiment can find out all by himself, he had to get creative, and if you look closely, the gyro he invented looks a little different from what one would expect. It is suspended by a thread and just so touches the base to keep it stable. What is what is very little known is that the gyros, when suspended on a thread, will rotate on their own independent of any drift precession. This inherent rotation can be controlled with a screw to squeeze the thread so you can get the rotation you need to be sold as reflecting Earth rotation. I doubt onlookers then and now would have had the wherewithal to go and calculate the expected drifts per latitude and compare them to what they saw. They saw it moving, and voila, the Earth is rotating. Sounds very familiar. Let's see if we can find that set screw to tune the rotation on the surviving model. If you do your own experiment, you will find this. Here are 6 minutes, the time frame in which the pilot was supposed to adjust for the apparent drift due to Earth rotation twice. Yet, here we see that there is absolute zero drift, and if you use a motorized gyro that can run for hours, it will remain fixed and steady for hours. Okay.
Alan, could you get a little closer to the mic?
Sure.
You're a little bit soft. Sorry, thanks.
You're good. You're good. Actually, I think it's probably because this has been turning down by default for no reason, and I forgot to turn it back up. So let me know. Did that help as well?
Sorry.
Yeah, all of a sudden Linux has a Microsoft issue.
You're having a Windows issue. Yeah.
Dude,
Stone would be laughing.
It's very bizarre. I could fix it with a simple hoodly daddle, but honestly,
I almost transferred to Linux for that specific issue. So now that it has it, Windows forever, baby.
Oh man, dang it, we could have had you, dude. All right. Okay, so but the question was about inexpensive resources. Your iPhone wasn't exactly inexpensive, but you already have it and it costs you nothing to use it. Get a good level app and put the phone on your table and then set the screen time to infinite and just wait. While you're waiting, you can ask one of the LLMs that you would what you could expect. Here's the prompt and the answer that I got. Prompt: we were talking about gyroscopes and cell phone level apps. If I calibrate my level app to my writing desk, and it should take that as the absolute information, like the direction of a gyroplane, wouldn't it also undergo an apparent drift that needs to be corrected, like pilots are instructed to do so? The LLM's response. Answer: excellent question. You hit it. Dude, the classic. You hit one of the fundamental principles of inertial sensing. Short answer is absolutely yes. Your phone's level app, when used in this way, is acting like a simple gyro-stabilized artificial horizon. And it is subject to the exact same type of apparent drift that the pilots must account for. When you calibrate your phone on your desk and you're telling it this orientation is level, your phone then uses its gyro compass to track all rotations away from that initial position. This is called dead reckoning. You've told your phone that your desk is the unmoved universe, and as the Earth rotates, the phone's gyroscope base senses the orientation, in inertial space, and it will slowly drift relative to your desk. If you left your phone perfectly still on the calibrated desk for 12 hours, it would eventually read 180 degrees. 12 hours later, still nothing, still zero reading. On your next long haul flight, you can use the level app to chase the alleged curvature by simply calibrating it to the fold down to the table in front of you. And when you have reached your cruising altitude, it doesn't matter if you're actually level. By calibrating it, you declare it is level because all you want to see is the change called the apparent drift. Over the course of a couple hours, the flight must change orientation relative to the initial position if the flight is following a spherical ground at constant altitude. Now, Stone made a video kind of refuting this premise, like that this is like the wrong device to use for that. But can't remember the specifics on that. If the iPhone is too complex and inscrutable inscrutable for you to get yourself a simple air-driven directional gyro from eBay, guaranteed no electronics, just a spinning gyro in air attached to a compressor. Move it around and see if it reacts to your movements. If yes, then put it on a stable platform cage, then cage it, and then wait. It shouldn't be long until you see the change, but don't hold your breath, as you'll be disappointed. And because you are not moving now, the drift due to mechanical loss will also be zero, which makes the total change zero no matter how long you wait. Unlucky. Wasn't there a video of someone using an old mechanical gyro from a plane, and then it had like its own drift to it? Like it had, and they were like, "Oh, that
Yeah,
air is just a secondary drift."
that was our boy
That was
Jesse.
Jesse.
Yeah, our boy
Oh,
Jesse putting forth the only gyro compass scope from a junkyard, which it is showing Earth rotation, but also it has its own separate drift that's unrelated. Don't worry about that. But this one is
Oh, that's
definitely
because
Earth
it's
rotation.
old.
Yeah.
He said that's
crazy.
because it's old.
Yeah. The older it is, the more it gets its own individual, separate, unrelated drift to any other mechanism. That checks out. All right. While we're talking gyros, I often hear of the ring laser gyro or the fiber optic gyro. Shout out to my favorite gyros. Mentioned in this context is a solid argument for a rotating Earth. I can't see that. On the contrary, I would argue that these gadgets are not gyros at all. They do not have the defining characteristics of a gyro, keeping attitude in space and precision under application of force. They are rotation measuring devices, and they work on the principle of that, which, by the way, demolishes Einstein's relativity. The Sagnac effect. You can't have Einstein and Sagnac at the same time. One has to give because Sagnac works and Einstein never presented anything that could actually work. He would have to go. Very true. If a split light beam completes a circuit at the same speed as the device is moving out from under it, there's not going to be a phase difference when the light beam recombines. The only way there could be a phase difference is if the path length is preserved through absolute space and the light beams traveling counterclockwise to one another complete their circuit at different times. And that's exactly what they measure. They don't, the relativity predicts no change, so they predict no fringe pattern, yet there's always a fringe pattern that's proportional to the velocity that caused it or the angular rotation that caused it. This isn't just a rotation measuring device, it's also a linear motion measuring device, but it's kind of a whole another subject. But yeah, the old C plus or minus V measured in there. Watch the animation above attentively and you will see that the light of the blue and red particles that will hit the moving receiver, the gray particles, at different velocities. So Einstein's claim is that C plus V is equal to C minus V, which it does not hold, which is, that would create no change in C. And if that is, it is, of course, logically that C plus or minus V that causes the effect. This difference is dependent on the rate of rotation, and while its difference is relative motion, it shouldn't exist according to Einstein. That is the measured and translated rate of rotation. So yeah, not only the angular rotation rate in degrees, but also the linear velocity that creates said rotation. They could, you just square The distance of the fringe in the wavelength, and it's proportional to the linear speed. Another simple experiment is water. Oh no. If you aren't at the poles or the equator, there should be an axial acceleration of acceleration is equal to omega squared times the cosine, or times the radius times the cosine theta, where theta is your latitude in yellow here. So it shows the latitude dependent variation based on the angle relative to the central axis of rotation, or that center point. As water is known to follow the minutest acceleration, it would be higher on the southern shore than on the southern rim in any vessel for that matter. Take a large vat and place a spirit level over it north and south orientation, and it will slowly fill with water until it gets close to touching the underside of the level. With tracing a light from the opposite side, you can judge the difference in distance down to the micron. For better light tracing, you can put a very even sheet of a floating material on the surface of the water and watch it slowly approach the rim. You can also coat a rubber duck with hydrophobic coating like X-ray or like Rain X, and put it in the bathtub overnight and check to see if it's arrived at the southern end of the tub. Next morning it the next morning as it should on a rotating sphere. So yeah, it should drift. Make sure there is no convection or other air movement allowed during that time. If you really want to get creative, put a bucket off the center on a rotating platform. You are not at the poles after all. Find a way of rotating it once every 24 hours and put the duck in, and then compare the results. Another inexpensive way is by comparing the observation with the scientific claims. Here's one go-to example. Go to Walter Bislin's Advanced Earth Calculator and let his math program for any object at distance of your choice. Should you live near Mirmara Beach in Santa Barbara, there's a wonderful case study available. 3 oil rigs on the island out to a distance of 30 miles. Oh yeah, the old Swan of the Black. So platform habitat 9.441 miles, globe hidden 42 feet. Platform hill house 6.2 miles, globe hidden height 15 feet. What you actually see is this: the horizon beyond the horizon is way beyond the rigs. When according to the theory, the rig should be beyond the horizon. So here we got the contrast removed a little bit to set the horizon line, so you can kind of see it back here. It's in the fog, but you can see that is the horizon line. Oops, accidentally misjudging the water as the horizon line. Unlucky. Dude, the globe is like a series of happy accidents.
Mathematically speaking, retroactively.
All right. Here's what a quick Google search wants you to believe. Walter Bislin's work provides a detailed, evidence-based tool and simulation on his website to calculate and demonstrate the curvature of Earth, frequently countering flat Earth arguments with precise mathematics.
Is that like his Wikipedia entry? Is that his claim to fame? That's what Walter Bislin is.
If you Google it, that's probably what AI will tell you about
Wow.
it. If you're like, hey, what's this website? It'll probably say something very similar to that.
Exactly that.
Yeah. Here, the evidence-based is simply a lie. This is purely math-based, and that the math, in turn, is premised on and empirically and not only unverified but unproven, but proven as a false assumption that the Earth is spherical. The above observations would be enough, but you can hold your own libitum or ad libitum. Here's the observation from Slovenia across the Adri to Italy. Top, what I actually saw, and bottom is what the precise math argues it would want you to believe, or argue that you must see. So top is what he actually saw. So we got this nice mountain peak here, And this is what the Bisland model predicts you should see. So I'm guessing all of this should have also been hidden, and then most of the mountain should have been gone. If you're curious about, if you have, if you are curious and have a little pocket money to spend, you can get yourself an IR camera with a wavelength sensitivity of around 830 nanometers. And your distance viewing capacity will explode, leaving Bislands playing in the sandbox. Infrared also eliminates all refraction arguments, so quickly at hand to the globe Earth defenders because it refracts less than visible light. Here is Mount Jacinto, was seen with an IR camera at 123 miles. Again, Bisland would predict that the peak not be above the lower yellow line, but there it is in all its glory, nothing left of the imaginary curvature. So here's where the mountain is. Here's where they predict it should be based on that distance. That's crazy. If you have a real dedication and time on your hand, dive into the telemetry programs, and a whole new avenue of disproving public opinion opens up. Here are multiple photos of the same surroundings on the moon. Telemetry tells us that those surroundings are arranged in a 200 feet 200 feet radius around the lunar lander. In other words, all the studio. I don't know, what is he talking about getting telemetry data from? I don't get it. What is this? Do you
Red
get
moon dust splatter? I don't know.
nah. Yeah, I don't know what this is supposed to be. Or take your IR camera on a flight and feed the data into your telemetry program, and the ground comes up flat as a pancake. Bottom part of the image here. I don't know what this is supposed to represent.
A telemetry program, but I don't know. Is that the moon? And that's us.
The white numbers and the little blue guys on the left are the positions that the unit was in when it took the shot. Took the angle, took the picture, and to produce a slice of what you see on the right. And
So how many slices do we have here?
down below, you're looking at the profile more. It's just a 3D manipulable scene.
So what's he? Do you get what he's trying to say here? Like what this is? And also, thank you for showing up, Stone.
No, I haven't tuned in early enough to catch the full context here.
Okay, yeah.
There was none. He just goes right into this.
Yeah, he just kind of was like, so like up here he was talking about infrared, looking at the mountains, and then he's like, if you have real dedication and time on your hands, dive into telemetry programs, and a whole new avenue of disproving public opinion opens up. Here are multiple photos of the same surroundings on the moon. Telemetry tells us that the surroundings are arranged in a 200-foot radius around the lunar lander. In other words, a studio scene.
Oh, he's
But I
saying
don't-
the telemetry data only extends 200 feet out.
So is this all Brenner, or is he referring to someone like Jay Tolan who uses a lot of AI, or IR rather?
This is supposed to be, so this one's Brenner for sure, or he says that this one's his, where he saw this mountain out in Italy, and then this is what the globe predicts he should have seen at the bottom here, that this whole island and most of the mountains should be gone. And then he gave this example. I think this one is from this one looks like a Jay Tolan one, if I'm not mistaken. And then I don't know what this is. Like, so telemetry
If you look in
moon
the
data.
comments section,
Oh yeah.
if you look in the comment section of that, there, he's talking about telemetry. Somebody was commenting on Jennifer Georgia Chris Harrington. Maybe that's where it comes from. I don't know, but it just he's mentioning telemetry and photography.
Telemetry and
The comments
photograph
below.
horizons where they don't belong, and assumptions, and Georgia and Harrington haven't, quote, explained anything. They have explained away this yeah. Is that what you're talking about, Dave?
I don't know.
Or is
I don't
there
know who those
another
people
one?
are.
Yeah, I don't know if that's what they're referencing for the telemetry instead of what you were thinking. I don't know.
Yeah, it would be nice to learn more about that. All right, but yeah, that is the first one there. So it ends on IR images, completely showing that there's no drop over distance and removing the refraction. We should be able to see exactly how much of that mountain is not visible because of Earth curve. So the next one we have is, do space agencies believe in a flat Earth? So Dean Helton here says no, because they can't do their work on a flat Earth model. That may sound plausible to those who never study the work of space agencies in printed detail and just believe everything they get as served by the media. But as soon as you actually look up their work, you'll find the words flat, non-rotating Earth with a stationary atmosphere is the default setting for all calculations, not only by space agencies, but by military, Air Force, and meteorologists, and civil engineers, etc. Stone, there's some diagrams in this one that I can't wait for you to look at.
I
Um,
see.
Okay, so here's the paper published from NASA's Air Force from Georgia Tech, which blows Helton's argument right out of the water. Georgia Tech, a model frequently used is the flat, non-rotating Earth. A temperature is assumed to either be constant or increase or decrease monotonically with the altitude, or to be stratified. So gravity, so static atmosphere, guys, that varies with at altitude as a
So
function
R
of the.
squared is irrelevant now too. I love that.
Yeah, they just take it right out of there. Gravity is assumed to be a constant as well. Because many people never look under the hood of their own vehicle, let's do it for them. Let's start out far away from NASA. In the USSR in 1957, a dissertation was defended in the Scientific Council of the Institute of Physics of the Earth about the dispersion of light in Earth's atmosphere. On page 20 of 100, we find the words near sun, flat Earth, firmament, located at various zenith distances. In the general public, these concepts are taboo. In the real world of science, in the real world of science, they are the default setting, as we will see.
That's the same paper he referenced in the other one to start, I think. So we already went through that one, right? That's the zenith measurement diffusion of light based on the sun's proximity.
Yes, sir.
We start out with the same one. All right, cool.
Yep. And then here is a paper by the Army Research Lab where it's written in the title, Propagation of Electromagnetic Fields over a Flat Earth. And on page 7, we find the wording, flat idealized Earth. Pay attention that it does not say idealized flat Earth, but a factual flat Earth idealized by assuming a constant permittivity and conducting. So here's the
Yeah, that's
quote.
so important as a distinction because
Yeah.
the Globers' main argument against all these papers is that they're just assumptions and that they make safe assumptions. And their other example as well, they also assume there's no atmosphere and there's people and there's constant for like all those are assumptions for simplicity, and they say that's the cause. But this says it's not using the idealized flat Earth; it's the wording for the flat idealized Earth, and that's a huge difference.
Yeah. Yeah. So he goes on to talk about that here with the effective military and law enforcement applications of high power microwaves, the HPM systems, in which the HPM system is the system and the target system are on or near the ground or water and require microwave power density to be target maximized. The power density at the target for a given source will depend on the destructive and constructive scattering of the fields as they propagate to the target. The antenna designed for the HPM system includes addressing the following questions about field polarization. Should the fields of the transmitting uh, antenna produces be vertically, horizontally, or circularly polarized? Which polarization maximizes the power of the target? The question of which polarization best couples to the target is beyond the scope of this report, but while this report does not completely answer these questions, it addresses the interaction of the radiated electromagnetic fields of the fields with the earth ground. It is assumed that the transmitting antenna and the target receiver are located above but near the surface of the flat idealized Earth, constant permittivity, epsilon, and conductivity, sigma, for the ground. The first and ideal vertical pole oriented along the z-axis perpendicular to the ground is addressed. The horizontal dipole, parallel, in parentheses or whatever. All right, the same research center publishes a paper about the attenuation in the lower atmosphere. So energy budget model to calculate the low atmosphere profiles of effective sound speed at night. Page 16 clearly states that the input of the data is to a flat Earth. Section 3.2, approximations for short-range acoustic attenuation. To briefly examine the short-range acoustic attenuation at night, we use a low atmosphere profile of wind speed, temperature, and relative humidity shown before as the input to a flat Earth non-turbulent acoustic propagation model called the Windows Scanning Fast Field Program, otherwise known as the WSCAFFIP. This acronym is the numerical code developed for assessing the environmental effects on the short range acoustic attenuation. That acronym determines the acoustic attenuation as the relative sound pressure loss with a range and azimuth for a given frequency to the source, from source to receiver geometry. So line of sight sounds like. And then the acronym contains propagation algorithms that represent the effects of the atmospheric refraction, diffraction, absorption, and reflection or ground impedance on acoustic transmission. So, and a paper about acoustic arrays to locate helicopters. Computationally efficient algorithms for estimating the angle of arrival using acoustic arrays by Jeffrey Goldman. Excuse me. On page 17, we read that the whole model is based on signal bouncing off of a flat Earth for the signals in the far field. So section 3.3, the multipath model. Figure 6 illustrates a simple model for the multipath, which is based upon a signal having a single bounce on a flat Earth with propagation that is described by ray tracing for the signals in the far field. The microphone is at a height h above the ground, and the complex reflection coefficient that is potentially frequency dependent is given by rho of omega,
Yeah.
which can be approximated using empirical data. The signal propagating along the direct and indirect path some generate. I'm guessing they generate the multipath model. And on page 30, we find out that the discrepancies can be attributed to the violation of the assumption of the flat Earth model. So letting the phase vary from minus 180 to positive 180, the phase that produced the matched was selected. The results are shown in figure 17 for a signal spectral peak for a frequency of 21 to 27 hertz for a reflection coefficient with an amplitude of 1. The results are based upon harmonics at higher frequencies were almost random and were not included. The results for low frequencies below 27 hertz are reasonably consistent, but not close to the anticipated result of the reflection coefficient phase of 0 degrees. The estimated phase reflection coefficients have a dependency range. This may be caused by the violation of the assumption of the flat Earth model. So what exactly does that mean? What are they saying there?
No idea. That's
So
that's pretty cryptic.
Yeah.
it may be caused by the violation of the assumption of a flat. So the estimated phase of the reflection coefficients, which are dependent on a single bounce on the flat Earth, have a dependency on range. This may be caused by a violation of the assumption of a flat Earth model. So they're saying that if there's an obstruction in the way, it doesn't work, is what I'm interpreting that with. Like if it's not line of sight for the I don't know, for the bounce, it's like it's not going to go over something. The same agency about projectile trajectories, a pet argument for the ball Earth folks. Adding liquid payload effects to the 6 DOF trajectory of spinning projectiles.
So that's 6 degrees of freedom.
Oh, thank you, sir.
Hmm.
Or otherwise known as the 6 DOF. but the calculations used explicitly assume a flat Earth. Oh no. Projectile flight dynamics, not to be confused with flight kinematics. A 6 degree of freedom rigid projectile model is employed to predict the dynamics of a projectile in flight. These equations assume a flat Earth. The 6 degrees of freedom comprises of 3 translational components describing the position of the projectile's center of mass and 3 Euler angles describing the orientation of the projectile with respect to the Earth. Figures 1 and 2 provide a visualization of the degrees of freedom. I would love to go back and look at those diagrams. The argument always goes like this. Oh, it's much simpler to calculate, but okay. It's also completely worthless if in reality there were a spinning ball that caused the rotation, which is an acceleration, and that can't be neglected. But it's just,
That's such a good response.
it's just so small that it doesn't matter. It's like, well, then it's not real. Like we could just disregard it. Okay. Let's go back to NASA and see how they calculate trajectories for damaged craft. The general equations of motion for a damaged asymmetric aircraft. So there is a renewed interest in dynamic characteristics of damaged aircrafts, both in the order of to assess survivability and to develop control laws to enhance survivability. This paper presents a set of flight dynamic equations of motion for a rigid body, not necessarily referenced to the body's center of mass. These equations can be used when the body loses a portion of its mass, and it's just desire to track the motion of the body's previous center of mass for the reference. So it's just basically kinematics based on where it's at. Doesn't have to be center of mass related. Furthermore, the results for the equation present in this paper and the equations of the standard aircraft simulations are compared to the scenario involving a generic transport aircraft configuration subject to wing damage. So right in the beginning, it's made clear what the situation of these calculations are used for them to be valid. So down in section 2, the rigid body equations for motion reference to an arbitrary fixed point on the body. There are several approaches that can be used to develop the general equations of motion. The one selected here starts with Newton's applied to the collection of particles defining a rigid body. Any number of dynamics or physics books can serve as the reference. In this paper, the rigid body equations of motion over a flat, non-rotating Earth are developed and are not necessarily referenced to the body's center of mass. Such equations will be used in the next section when the body loses a portion of its mass and it's desired to track the motion of the body's previous center of mass frame now that the center of mass has been moved to a new position. So literally just plotting out the trajectory of where it is based on its velocity at that time as it's, descending or whatever angle that it's going at. How's it going to continue? And they're just treating the Earth as flat over that and to make the predictions. Crazy. Next, a NASA paper about wind compensation for unguided rockets. So technical note here, calculation of wind compensation for launching unguided rockets. Predictably, we have the page 8 with the familiar wording. A trajectory simulation incorporating the requirements is presented above in reference 8. In addition to the above requirements, this simulation assumes a vehicle with 6 degrees of freedom and aerodynamic symmetry in a roll, and the missile position in space is computed relative to a flat, non-rotating ground. This trajectory simulation was programmed on the IMB 704 electronic data processing machine and is the basis for the trajectory computations made in this paper.
That would be IBM International Business Machines. You all know and love them, I'm sure.
Mm-hmm. Let's see. Another paper that words it slightly differently. Determination of angles of attack and side slip from radar data and a roll stabilized platform. So here we got this document here, determination of the angles. Abstract. The equations for the angles of attack, slide, slip relative to both the rolling and non-rolling body axis system are derived for the flight vehicle for which the radar and gyroscope altitude data are available. The method is limited, however, to the application where a flat, non-rotating Earth may be assumed. The gyro.
It literally says, "Hey, it doesn't work unless the Earth is flat and not rotating." That's what it says. Not only we're assuming it doesn't work without this, actually.
The gyro considered measures altitude relative to the inertial reference in a Euler angle sequence. The particular A pitch, yaw, in particular, A pitch, yaw, roll sequence is used in the example of the derivation. Sample calculations are based on flight data are presented to illustrate the method. Results obtained with the present gyro method are compared with another technique that uses onboard camera data. So, quote, only where a flat, non-rotating Earth may be assumed. Now, where would that be? Where would it be? Stone, when you're trying to land a plane and you have radar that's telling
everywhere?
Would that just be anywhere? Okay. In the fast high flying SR-71 has been off. The fast and high flying SR-71 has often been named in the discussions about flat Earth because NASA has a paper on this topic. So let's see how they treat it. Stability control and estimation for flight test results for the SR-71 aircraft with externally mounted experiments. The aircraft equation for motion uses the PID analysis and are derived from the general systems of 9 coupled nonlinear differential equations to describe the aircraft motion. These equations assume a rigid vehicle in a flat, non-rotating Earth. The time rate of change of the mass and inertia is assumed to be negligible. The SR-71 configurations studied herein, like most aircraft, are basically symmetric about the vertical centerline plane. The symmetry is used along with the small angle approximations to separate the equations of motion into largely independent sets describing longitudinal and lateral direction motions of the aircraft. The equations of motion are written and the body axis referenced to the CG and include both state and response equations. The applicable equations of motion are as follows for the longitudinal lateral direction axis.
CG being center of gravity. Woo!
Ooh, thank you, sir. What about PID? Any PIDs? Because I know a RuneScape term that fits that.
It's a personal interface device. I don't know. I take that from the Windows context. PID.
Okay. I'll let you have that one. I was going to claim it for RuneScape though. All right. So now, if they don't think it's necessary to calculate the contribution of a rotating spherical Earth on the behavior of a vehicle flying at over 2,000 miles per hour, then the only conclusion remains that it is in fact not necessary. Here's a good one, showing that you can find a flat Earth, the mantra nowhere more than the scientific papers. So here we got some more examples. Path loss measurement in forested environment at the very high frequency. So multiple path data on page 16. In this section, we discuss the data and the measurements described in section 2.2. Figure 9 plots the transmission loss as a function of the transmit antenna height for 145, 223, 300, 435, and 910 megahertz, respectively. Their receive antenna has a height of 2.7 meters, and the range was about 410 meters for all frequencies except 435 megahertz, where the receiver height was 3.6 meters at a range of 200 meters. The expected transmission loss in decibels over a flat Earth is given by the equation 2. Page 17. Comparison methods to theory of transmission over a flat Earth for a range of 410 meters and a receive antenna height of 2.7 meters. And then we got the frequencies listed after that for A, B, and C. Here's our plotted graph. Now it looks kind of linear to me. What do you think? dBs. And what's this supposed to be? The distance, or what's the bottom graph? All right, figure 9 continued. Comparison of the measurements to theory and transmission over a flat Earth for the rest of the effective range for the other frequencies that were left out in the first part. Page 19, here it is worth noting that the discrepancies are attributed to the obstacle on the ground, not the inadequacy of the flat Earth model. And with the loss over the Earth in decibels given by equation 2, equation 2 assumes a flat Earth, lossless and perfect reflecting ground. The measured data figures 11 are for the transmit heights of 22 meters, a receiver height of 5 meters, and for the HH polarization. Agreement within about 5 decibels is obtained between theory and measurement. The difference between the theory of propagation over a flat Earth given by equation 2 and the measurement is because the measurements were made on an irregularly lossy ground with obstacles on both sides.
There it is.
Yeah. And the measurements, the difference between the wow. All right, so 20 page based on a flat Earth theory. The local trees and brush can cause such variations after the data were inspected. It became apparent that they tended to agree with the theory given by equation 2 plus some fixed attenuation, and therefore allowed us to develop an analytical expression based on flat Earth theory. No way, that's illegal. This fixed attenuation is independent of range but varies with frequency. Independent of range. Page 23. The results generated by the model are shown as curves. Figure 15 plots the propagation and data loss in decibels for the selected antenna heights as a function of range. The transmit height of 22 meters and the received height of 2.7 meters. The data in figure 15 compares loss over flat Earth theory given by equation 2 in section 4.1 and the analytical model given by equation 4, and then that's it for that one. And then on page 28, we get the conclusion with flat Earth twice being mentioned in it. So conclusion from the paper that we're just reading, the measurements were made in the clearing in a clearing area that agreed with the theory to about 5 decibels, and the deviations are largely because the clearing was not perfectly flat nor without obstacles. Because the HH polarization clearly gave the best penetration through the woods, all the following conclusions are based on HH polarization only. The propagation loss through the woods tends to agree with the theory, plus a fixed attenuation. Therefore, we develop the analytical expression by adding the attenuation to the theory of loss over a flat Earth. The results of the expression for determining the propagation loss in decibels is given by this equation here, where H equals receiver height, or HR is receiver height, HT is the transmitter height, R is the range or the distance, lambda is the starting wavelength, and frequency is the frequency in megahertz. And that's all. There's no Earth radius there? What am I missing here?
Why would they bother with lambda and F? It's the same thing. One is the reciprocal of the other. Wavelength and frequency?
You'd think.
It's all about C, right?
Yeah.
Wow.
I mean, I guess the value is going to represent the same thing too, right? So yeah, I don't know. They do that sometimes, and this is an older one. I noticed that. So like the old interferometry papers, they'll sometimes write like frequency and wavelength when they just mean C, you know? So maybe it's just one of those deals. But when have you read so many times in a paper that they're mentioning flat Earth? If you want to bathe in flat Earth, don't join a flat Earth group. Go get research papers. They can't state it often enough. Whereas the flat Earthers are a bit coy about shouting it out. I don't know. We've been
The best flat Earth proof is in papers. That's like our motto.
It's the mantra around here. Another pet argument is that radio waves, which are claimed to not be able to propagate over a flat Earth, was found in Brown University in this paper. So, the extension of the Summerfield's formula for propagation waves over a flat Earth to different conductivities of soil. And shout out to Sommerfeld because he's also the lad that came up with the creeping wave diffraction formula for electromagnetic propagation over a spherical Earth. So we actually can apply this to a future upcoming Battle of the Beams presentation. See, in this paper by that was just mentioned here, we find on page 18, in most of the topics to be discussed, the problem is to describe the sound field in a region of atmosphere over a flat Earth. More specifically, the chosen aim is to state the sound pressure P at any point, capital P, due to a source, whose pertinent properties are assumed known, localized near another point referenced Q. Unless stated otherwise, that's the end of this section. Flight simulators are another topic, another heated topic of discussion. As Dave likes to say, Dave, what's that famous saying you like to say? You can't plan a lane on a spinning ball.
You must be watching the game.
Yeah. The old sport ball. Who's throwing the hoop through the thing or what are they? What sport is it now?
Touching down with that home run with the fieldy goalie thing.
Oh, yeah. The old wide receivers throwing the hatchback or whatever. All right, so
In a
design
single putt.
Yep.
Nailed it.
Design and implementation of the flight visual simulation system. Abstract. The design requirement for flight visualization system is studied. The overall structure and development process are proposed in this paper through the construction of a 3D scene model library and the aircraft model. The rendering and interaction of the visual scene are implemented. The changes of aircraft flight altitude. The changes of aircraft flight altitude in the visual system are controlled by real-time calculations of aircraft aerodynamics and dynamic equations of and flight simulation effects is enhanced by this kind of control. Several key techniques for optimizing 3D models and relative models for large terrain modeling are explored for improving loading ability and rendering speeds. Experiments show that with specific function and performance guaranteed as a premise, the system achieves the expected result with high precision for real-time calculations of a flight altitude and smooth, realistic screen flight.
You have to zoom a
3.
bit when you go to those small ones. Those are hard to read for the crowd, I'm sure. Yeah, much better.
Yes, sir. Section 3, the mathematical modeling of the flight simulation. The aircraft motion simulation is as an important part of the FVSS directly affects the reliability and authenticity of the system. Flight motion simulation effect can be greatly improved by relative mathematical models of aircraft flight dynamics. In this paper, the FVSS is based on two assumptions. Oh no, let me guess. Assumption 1, flight area is the space above ground level where the rotation of the Earth and the curvy motion of mass center are to be neglected. All right. And B, that the aircraft is an ideal rigid body of eddy and the influence of the aircraft body, elastic deformation, and rotating parts are not considered. Very cool. Now here we have some nice diagrams for you to dissect, Stone. Here's some papers about gunnery. Field Artillery Manual Cannon Gunnery, April 2016. Distribution approved for public release. Headquarters, Department of the Army. First thing you meet is the explicit exclusion of rotation and no mention of curvature or Coriolis, otherwise known as Coriolis. So the standard conditions, we got temperature, air density, wind, gun range target, MTP at the same altitude, accurate range, no rotation. Material: standard weapon, projectile, infused, propellant, temperature, level, truitions. No.
Trunnions.
What is it?
Those are
Tree-
trunnions. It's like
tr-
Funyuns almost.
Yeah, I was like, is that true? Okay, trunnions and precise settings. Firing table for muzzle velocity and no drift. I have yet to find a paper where the calculations are based on what is claimed to be reality, the spherical rotating Earth. P.S. Here's the bottom line of the handwriting and the comments so far. Rotation and sphericity are absolutely the case, but they are also negligible, letting us treat the Earth as if it's flat and non-rotating. But we absolutely have to incorporate them in the calculations for accuracy, but then simplified for flat Earth calculations are good enough. And round it goes, depending on whatever comes handy at the moment. Now, let's look at the case where curvature is incorporated. Study the picture carefully and record your reaction when it clicks. If it doesn't physically hurt your brain, you have a ways to go. So we have the how Earth's curvature reduces elevation angle. We got your line of sight, and we got your corrected for Earth curvature angle. What's LOF? Is that the
That's a
line
line
of
of
fall?
fire.
Line of fire.
A line of fire. What the gun is aimed at.
Gotcha. So if your line of fire is aimed up here, you're going to come down here. This would be if the Earth is flat. But if the Earth is a globe, you have to correct it and shoot at this elevation so that it
Yeah, he's
kinda
actually
so-
correcting for curvature.
so that you bank the shot in. So this is the uncorrected. This is the corrected. So they bring it down, shoot from here. Okay. Yep. All right. Projectile
Notice
falls.
that the line of sight never touches the water.
That would
Doesn't
be
matter how
illegal.
far away the craft is. There's some kind of little dip there. You get close to the water, but you can still see all of the craft.
That would be illegal. All right. Let's see. This paper gives us an illustration to serve. This paper gives us an illustration that serve well to answer the range of questions. First, the range dependency on gun elevation shows that the flat Earth default setting for long range shots. So they go from this diagram to this diagram. How range decreases as elevation increases from 45 degrees to 90 degrees. So,
But that's just vector addition. That's got nothing to do with the shape of the surface across. You're just firing it more straight up into the sky so it lands closer to you. Because it's coming out of the gun at the same velocity for each fire, right? So that's what you got to do.
right. So to get it at a long range, you have it tilted not as high, and it just goes, basically with the flat Earth approximation.
Well, they're saying you do the 45 thing and you're going to get the best range. If it's exactly 45 degrees, you're going to shoot at the farthest. That's what they're saying. That's just a cosine function, really, right?
Then the summary of all influences include under points 3 and 4 in curvature and rotation, but does it really? Initial projectile velocity, vertical parallax, force of gravity, rotation of Earth, curvature of Earth, range wind, super elevation of target, air resistance, factors of range ballistics. Regarding point 3 curvature, the line of sight between the ships is a straight line, and the bulge between the ships does not have any effect on the trajectory, only on the angle the ship presents to the ordnance, and has no one yet shown an object leaning away from you at great distances, as it should on a sphere. This is actually something that I was talking to Icon Science that about like a really, really long time ago. And he was saying that, basically you would never be able to actually measure a tilt away from you. And the best way to do it would just be using the stars. The old change in position of stars over distance to confirm the shape. So no far away from the mountains ever lean away. And this goes to like the Canigou thing where we get the perfect vertical silhouette. It's not tilted or distorted or diffused in any way. It's a literal, hollowed out silhouette exactly of the peak that should not even be there at all. No airplane going over the horizon ever presents its belly as it should when it's following down a curve, but just diminishes in your field of view, all while remaining level. So the bulge here is purely illustrative with no bearing on the result. That shows that you can officially incorporate a feature without having to actually do it, purely cosmetic. Would they be earnest about incorporating the curve, or would they have you follow the claim that the projectile's Earth is it, or that the projectile's path is a truncated elliptical orbit around Earth's center? So this is what it looks like when you're actually, shooting the gun or dropping a cannonball, etc. It's following an elliptical path around Earth's center. But they never do, otherwise the equations for fall time and thus the range would reflect the time is the square of 2 times the height over g minus the velocity squared divided by the radius of Earth. And then the distance, of course, from that would be equal to the velocity times time, which was equal to the velocity times the square of 2 times the height over gravitational, the g constant minus the velocity squared over the radius again to create this. Regarding point 4 in rotation, I have yet to find a gunner who adjusts his aim according to the target's cardinal direction and the event's latitudinal position, as he would have to. Would the rotation play a role? Not only because of the alleged Coriolis deflection, but because of the alleged
Eotfos.
Yeah, what is it? Eotfos
Eotfos. Yeah.
effect, which is claimed to be so strong that ships in the 19th century moving at bicycle speeds could record it. Now imagine a bullet flying at 1200 meters per second eastward, which has a 1600 meter a second effective velocity at the equator, lightening the projectile to the gravitational effective potential or whatever calculated by g minus the velocity squared over the radius, and that comes out to be 9.375 meters per second, while westward, and then it would be 9.72 meters per second, meaning the gravity would effectively be the gradient from 9.73 meters per second to 9.72 meters per second, moving east to west. In addition to that, the projectile fired on any latitude other than the equator, aimed dead east, would not follow the eastward path because it would go in a straight line. It would follow a great circle route, whereas dead east, located on the 45th latitude, for instance, represents a circle, and bullets don't go in circles. This brings us to another contested topic in the comment section. How are freely moving objects persuaded to follow a circle around an axis instead of following Newton's first law of motion? With gravity being the only available force, this would look something like this. Everyone would agree that this is as silly as it is impossible, but when it comes to earthly fantasies, people are more than willing to accept it. So you're rotating you're like spinning a tether above your head, and instead of it being relative to that center point of your hand holding it up, it's relative to your center of mass. Is that kind of what they're saying?
I think that's what he's driving at. Yeah.
At the 45th lattie, for instance, there's nothing that keeps a freely moving object at a constant distance to the axis of rotation. Newton's first law would make it move straight until the green arrow becomes axial, and that is at the equator. Yeah. Bottom line, curvature and rotation are only cosmetically incorporated. In practice, nothing of the sort ever happens, as it is not necessary, because it simply is not a case of factual reality.
Yeah, these math whizzes just have this deep-seated desire to simplify the math. Yeah, right.
What about those artillery manuals? Dude, I saw one artillery manual that was like, the effective range of this weapon is, let's say 1600 meters or something, right? And then they were like, if you're shooting a target outside of that, you have to move the weapon system. You like accounting for curvature in terms of like, oh, you need to tilt it higher or lower wasn't a thing. It was it was literally, if it got to a point where you were, having to account for earth curvature, you were outside of the effective range of the weapon system and you had to physically move it. That's not even, that's so crazy. That's not accounting for earth curve. But that was the best. That was the best one that I've seen for it. All right. So, any thoughts, comments, or concerns, or anything, lads, ladettes? We got this guy here that says these calculations are based on a spherical rotating Earth, so of course he didn't find any. These are cherry picked. Rotating Earth. Let's see what we got here. Rotating Earth. What is this in relation to?
Latitude-dependent gravity.
Literally just calculating. Okay, so nothing. And then the final report. Modeling over a spherical Earth by David Zitter.
It's all simulation.
Just simulation stuff. Take into account the shape of the writing as it rotates on its axis. 14 pager. Maybe we'll read this one next as a follow up to see what they what they try to incorporate or whatever. Because I heard they actually changed because like this whole simulator thing was pointed out a while ago, and I heard that Microsoft updated their flight simulator to like add they patched in the spherical Earth, guys. It wasn't quite as good as it is now because before it was representing a flat Earth, and now that they've patched it, it's even more better. So we'll take a look at those perhaps. And yeah, this right here, the 4.4 mile shot from a couple of years ago. They didn't account for Coriolis or anything like that, and they shot south by southwest, which is like diagonal to the. It's basically if you're on a rotating object, the Coriolis force is going to occur when you're moving perpendicular to the plane of rotation. So if you're shooting southwest, you're gonna experience Coriolis. So the fact that they didn't account for any of that in there is dead giveaway. All right. Well, that has concluded the reading night, lads and ladettes. Hope everyone enjoyed, learned something new. I know I'm going to be looking at more IR photographs and tracking down positions and whatnot and seeing what else we can glean from this. Because I don't think I've ever seen a massive collage of like of them all like put together, showing the differences of what the models predict. But this is a great one to go over. So I'm going to be working on that. Liliana, it is time, as per your contract agreement, to do an ad read for Tobithius Maximus Decimus Meridius.
Sure. Well, I was just going to say real quick that I love how they say that, oh, just for easier calculation, we're just going to, leave it at flat and stationary just to make the calculation easier. That, oh my God, I'll bet you there are some people with, decent amount of critical thinking skills still left in them in NASA that secretly know that the Earth is flat and stationary, but they can't come out and say it for obvious reasons. What do you think?
Yeah. And to add on to that, I kind of feel like if there was a difference between, like, hey, we're going to train these pilots so that there's now certified as pilots and we can like, guarantee a level of expertise of what they're doing that's going to guarantee, your safety in flight, right? Because they don't just let anyone fly, your Southwest airline flight. They got to be a pilot. You got to go through some training, got to do these simulations. So I feel like if there was ever an accident or something, you could sue them for saying like, hey, you trained your pilots for no weather dynamics, no actual, dynamics of the earth. There should be like some kind of liability in that, but there just isn't any, and I think that's kind of a giveaway too, or maybe an unexplored avenue.
There's
Yeah,
also
they
the
have to
fact
treat it and use the air quotes, as treat the Earth as if, in quotes, it's stationary. Like that takes care of it right there. Just as
That
if, just land on it like it's not moving at all. Even though it's totally moving, and you have to be moving eastward at the exact same speed. But that's okay. Just treat it like it's not moving. Don't worry about the eastward tangential velocity. It's all good.
Yeah.
there's also
Yeah.
the fact that we do all our calculations on computers now, so there's no need to simplify it, especially if you want something accurate.
Yeah,
Yeah.
true. I've seen what you can do with a Python script, Brian. You get down to 18 points of decimal place. It can definitely
Yeah,
be
also,
calculated.
yeah, also how he talked about the planes, like you would see more of their belly if they were really going around. I've always seen that same phenomenon with these really wide vista time lapse pictures of clouds that are coming in from really, really distant, and you cannot see any kind of curvature at all. It's
None.
just so flat when the clouds are coming in from a really, really far distance in the time lapse pictures, videos.
Nice.
Yeah.
I don't know if it's really a good argument though, because if you think of it in terms of central angle, how many degrees would that plane actually be tilting? I don't think it's that much.
Uh,
Depends on
it
how
it
high and
would.
far away it is, I suppose.
Well, I mean, I think if you
Well, what's
had
it going to be? 20
binoculars,
miles? I mean, that's nothing.
Yeah, you don't really see them that far, huh?
if you had binoculars and it was enlarged, then what he said would be true in that paper.
Hmm.
Theoretically, yeah. What
All
he
right,
said.
Lily, you were supposed to say something about our delicious coffee product, which can be found at some
Yes,
website. I can't remember what it is. Lily, do you know what it is? It's
the brush tail coffee, so yummy. Yes, I drink it every day. And interesting thing that I discovered a while ago, I may have mentioned it before. I can't remember. But one time I was drinking coffee and I just, had a couple walnuts sitting there. So I just ate some walnuts along with the coffee. And just by coincidence, there was this gigantic big flock of geese that was flying in the sky above me, and I could understand what the geese were saying because they were honking so much. So I think when you combine the coffee with walnuts, you can understand the language of geese. They're honking. That's a discovery I made. So try out the brushtail coffee and eat a couple walnuts with it. You'll see what I mean.
you
Whenever
heard
the
it
geese
here.
are migrating, you have to wait till they migrate.
You heard it here first, folks. Drink brushtail coffee and you can talk to the geese. All right, we will be back on Friday night for the Friday Community Twitter Space. See what the lads and ladettes are doing over on the Twitters. And that's hosted by Brian Sweet and Ken. Shout out to the lads holding it down throughout the week. And then we'll be back again next Monday for Celestial Theodolite update number 30 something. And then, of course, Tuesday we'll return with a presentation or another reading night. See you guys later in the week.
This was a lot of fun, Alan. Thank you.
You're welcome, Lily.